of the most important processes for the type of work that we perform here at Austin Industrial is hazard recognition. Hazard recognition means finding or discovering things in our work that can cause an injury or illness to the people performing the work, the people near the work, or the work environment. In everything that we do, it is absolutely critical to discover the hazards and control them before they can cause an injury. Hazard recognition is a proactive approach to your safety. There are 3 stages to hazard recognition. The first stage is before the hazard occurs. This is analyzing the job that you're going to perform and finding those hazards that can lead to an accident or a near miss. The second stage is while the hazard has the potential to occur. This stage takes place while the work is being performed. It involves analyzing the work that is taking place and ensuring that we have identified all hazards and controlled them. The final stage is after a hazard has occurred. This is analyzing the hazard that has been presented and why the hazard wasn't controlled to begin with, and how we can ensure that it doesn't happen again. Identifying hazards before they happen is the most important aspect of hazard recognition. This is because controlling hazards before they can affect a worker eliminates the possibility of an accident. The first step in hazard recognition is how we get in front of accidents, anticipate what can go wrong, and eliminate the possibility of having things go wrong on the job. The first step that we take is to perform a job safety analysis, or JSA. A job safety analysis, or JSA, is performed for each and every task that we do. In other words, we want to plan the work and then implement the plan. The JSA is a tool that we use to plan safety into the work that we perform. All work that will be performed will be planned using a JSA. What this form accomplishes is a written plan for executing the job safely and has essentially 4 basic steps to complete. First, you will want to determine what you're going to accomplish in your job. This is a broad description. Second, once you know what you want to accomplish, determine how you will perform this job. This is a series of steps to get from the starting point of the job to completing the job. Third, once you know what the steps are, you can now identify what hazards exist in performing each step of the job. And finally, you can now determine how to control or mitigate each hazard that you have identified in order to keep everyone involved protected from the hazard. It is very important that we get beyond the superficial recognition of hazards. All too often we see complex jobs being performed, but only a handful of steps, hazards, or precautions are listed. The JSA is a 2-page document, front and back, that will help ensure that we have planned and identified all of the hazards, as well as determine how we will protect ourselves from these hazards in order to work safely. Now, let's take a step-by-step walkthrough on completing the JSA process. It is very important to understand the process of the JSA. The best method of producing a quality product is to work with a crew to write the JSA. Although one person may be writing the JSA, everyone on the crew must be involved to ensure the perspectives of all are captured, because everyone in the crew brings a unique experience and understanding. If possible, write the JSA in the work area so that you can visualize the work. Page 1 of the JSA form contains basic information such as lockout tagout information, basic job steps, hazards, mitigation of hazards, and tasks between the tasks. The first section is to write down the basic information about the job that you are going to be performing. This section contains important information that must be filled out completely. This section provides us with a very good overview of the job that we will be performing and basic safety information involved. In this example, we have provided sample responses written in red to show what information is expected in filling out the JSA form. Additional PPE. This is where we will write any other specific PPE that will be needed to complete the job. Think about the steps to complete the job and see if anything else needs to be listed. You may have to come back to this after determining your steps to complete the task. For example, in this job, we're going to need a respirator and a chemical suit while we break the line on the discharge pipe. Site location. This is the specific location within the plant where you will be performing the task. This is not the job site name. So in this example, we listed that we are working at Tank Farm and specifically the number 4 cyclohexane tank. Date. Place the date that you are writing and performing the work. Wind. Indicate the wind position is important for emergency evacuations, especially in the event of a chemical release. Task description. This is where you will list the brief description of what the task is. What are you trying to accomplish in this task? For example, we will be replacing the PCV valve on the cyclohexane tank discharge line. It's short, to the point, and basically lays out what we are going to do. Safety shower eye wash location. Identifying the location of the closest safety shower and eye wash station before starting work is very important so that you don't find yourself in an emergency situation and need to find the safety shower. Supervisor. List your direct supervisor here. Analysis performed by. The person who physically wrote the JSA will write their name here. Be sure to print your name. You will be signing the form later. This is a good time to point out that the JSA will be physically written by one person. However, it is expected that the entire crew involved in performing the job will participate and be engaged in writing the JSA as a group. This is important because everyone will bring different experience and perspectives to a job to develop a much better finished product. Permits required. In this section, you will list any required permits to begin the job. For example, a safe work permit, a line break permit, or a hot work permit. Number of EOs on the crew. This will be all of the people expected to work on the crew performing this job. Title of the person completing the JSA. The person writing the JSA will list their craft or job title here. While this information seems basic, it is important to have a good end product and an overall safe, quality job. The JSA form gives you a guide for using the hierarchy of safety controls. When dealing with safety, we have to follow the hierarchy of controls. The hierarchy of controls has a lot of different uses in the work that we perform. The range in the most effective control of hazards, such as elimination of the hazard, to the least effective control of hazards, which is personal protective equipment or PPE. Since hands are a focus area in the company, we will look at hand safety examples along with other examples as we continue through the JSA process. The hierarchy of controls is a range of methods to control hazards in a most effective to least effective control. The most effective way to control hazards is to eliminate or substitute them. Elimination of a hazard means to physically remove the hazard. Actually, removing the hazard itself is the safest way to perform the work. Elimination of the hazard can work in many ways. For example, with hands, instead of holding a striking tool in your hand, you can use a tool holder that removes your hand from the line of fire. Another example is if employees must work high above the ground, the hazard can be eliminated by moving the piece they are working on to the ground level to eliminate the need of working at heights. Substituting the hazard means replacing the existing hazard with something that does not add additional hazards. For example, with hands, this could mean using a rivet gun instead of hammering rivets into place. Another example may be replacing lead-based paint with acrylic paint. To be an effective control, the new product must not produce another hazard. Because airborne dust can be hazardous, if a product can be purchased with a larger particle size, the smaller product may be effectively substituted with the larger product. Can you think of other ways that we can eliminate or substitute hazards in the workplace? Engineering controls isolate people from the hazard. For example, this could mean using lockout, tagout, blinds, blinks, or double block and bleed in a hazardous energy situation. A crew might build a work platform rather than purchase or replace and maintain fall arrest equipment. Enclosure and isolation creates a physical barrier between personnel and hazards, such as using remotely controlled equipment. Fume hoods can remove airborne contaminants as a means of engineering control. Can you think of other ways that we can engineer the hazard out of our work? Administrative controls change the way that people work. For hands, this might involve mandatory rest breaks when performing repetitive motion tasks such as grinding or identifying and avoiding pinch points. Other examples of administrative controls include procedure changes, employee training, and installation of signs and warning labels. Administrative controls do not remove the hazard, but limit or prevent people's exposure to hazards, such as completing road obstruction at night when fewer people are driving. Can you think of other administrative controls in our work? The last line of defense for a worker is to use the appropriate PPE for the job. For hands, this may include choosing the right glove, such as cut resistant for sharp edges. Other types of PPE include welding hoods, face shields, respirators, harnesses, lanyards, and other types. All too often we rely simply on PPE for our sole protection in the workplace. And this results in accidents where the PPE was rendered useless in preventing the injury. The PPE we use has to be 1. Adequate for the task, and 2. Used with any other combination of controls, for example, elimination, substitution, engineering, and administrative. This section of the JSA gives us an opportunity to ensure that we have completed any lockout, tagout requirements to complete the job. If lockout, tagout is required, select Yes in this section. This makes us think about and answer 2 more questions if we need to perform lockout, tagout on this job. First, anytime we are performing a lockout, tagout, we have to list what is being locked out. This is accomplished using an Austin energy isolation list, or the customer will have an energy isolation list or energy isolation plan or energy control procedure. When performing a lockout tagout, everyone working and placing a lock on the equipment must review this plan. Second, when reviewing the energy isolation list, You must verify that all required signatures are in place before starting work. This could be the plant operator, the lockout tagout champion, an Austin supervisor, or other. If required, each person placing a lock on the equipment or lockbox will sign the energy isolation list. The next part of the JSA is to list the sequence of basic steps, the hazards involved, and the corrective actions and controls to protect the crew from the hazards. Your flow will begin with identifying the basic steps to complete the job. Once you identify your basic steps, you can then look at each step and determine the hazards involved with that step. Once the hazards are identified for each step to complete the job, you can then determine how you will protect yourself from each hazard that you identified. Listing the basic job steps to complete a task is extremely important for two reasons. First, it gets the crew thinking about the job and how it will be performed. Much of our safety is derived from simply thinking. This is why we review JSAs every day, because it gives you an opportunity to focus your mind on the task that you will be performing. When identifying the hazards involved with your work, it is much easier to look at each step and identify the hazards for the step than it is to look at the overall job and try and come up with hazards looking at the big picture. Without identifying the steps, you will be looking at the whole job and trying to come up with hazards for removing and replacing the pump and the motor. With the steps broken out like we see here, you are now coming up with hazards for performing the lockout tagout, performing the first line break, using a forklift, transporting the pump and motor, and using hand tools. You have 8 sequential steps that you can analyze for hazards instead of looking at the big picture and trying to figure out the hazards. This makes hazard identification much more accurate and efficient. Remember, this portion of the JSA is never complete until the job is over. If you change your work method or how you will perform the work, increase the amount of steps, or anything else, you have to stop and address this on the JSA. The JSA is an open-ended process, and we can always revisit it and make changes as our work scope, hazards, controls, and environment changes. For example, you may find out that the outlet line on the discharge pump is completely corroded, and you will have to remove it with a crane. This creates changes to the work scope, steps to complete the job, hazards, tools and equipment, and precautions in order to complete the job. Always stop to address the changes. Identifying the hazards involved is one of the most important aspects of the JSA, because if we do not identify a hazard, then we have no opportunity to control or eliminate the hazard that can cause an accident. This step illustrates why the JSA is considered a process, because to identify the hazards accurately and efficiently, you need to look at each step to complete the job and identify the hazards involved with each step. So you would start with step 1 and go through step 9. For each step, you would identify the hazards involved with performing each step. For example, step 1 is performing the first line break. The hazard is the possibility that the line contains some hazardous energy. Step 2 and step 3 is using a forklift. The hazards are forklift use, such as improper operation, not inspecting the forklift, or not using a certified operator. Step 4 is placing the pump and the motor on the dolly. Some hazards include load shifting and not being secured. And this goes on until you have analyzed each step and identified the hazards involved. Doing it this way gives the crew a much better opportunity to identify hazards than if you were just looking at the job as a whole and trying to come up with the hazards. Remember, this portion of the JSA is never complete until the job is over. If you change your work method or how you will perform the work, increase the amount of steps, or other changes, you have to stop and address the changes on the JSA. The JSA is an open-ended process, and we can always revisit it and make changes to our work scope, hazards, controls, or environmental changes. For example, you may find out during the work that you will need a torch to cut the bolts on the flange. This changes the tools and equipment, the hazards, and the precautions to complete the job. Always stop to address the changes. Again, we continue to understand how the JSA is a process. This part, and possibly the most important part, is to figure out how you can perform the job without having an accident occur due to the hazards that are involved. The JSA is a process because without successfully identifying the steps to complete the job and subsequently identifying the hazards for each step involved, you will not be able to identify the control measures that you need to put into place in order to control or eliminate the hazards involved with the work. To identify the precautions accurately and efficiently, you do the same thing you did on the previous step. You look at each individual hazard that you will face, and you will list what precautions you need to take control or eliminate the hazard. For example, the first hazard that we identified is having potential for pressure or liquid in the line. Our precaution is to lock out and tag out the line, which is an engineering control, to break the line away from you, which is an administrative control, and finally to wear personal protective equipment as if the line is charged, which is a PPE control. Another hazard that we identified is pinch points. Our precaution is to identify and avoid the pinch points, which is an administrative control. The 12th hazard on the list is welding fumes, and we will be placing a fan to displace the fumes out of the welder's breathing zone. This is another example of engineering controls. Remember, this portion of the JSA is never complete until the job is over. If you identify more hazards, you have to stop and address this on the JSA. The JSA is an open-ended process, and we can always revisit it to make changes as our work scope, hazards, controls, or environment changes. For example, you may find out during the work that the motor is too large for the forklift and you will need to use an overhead crane. This changes the tools, equipment, hazards, and precautions to complete the job safely. Always stop to address the changes. The bottom section of the JSA is to identify tasks between the task, or TBT. In our work, TBT accounts for over 50% of the accidents that occur. This tells us that a majority of people aren't getting hurt performing the job, but rather doing things between the jobs, such as getting tools, climbing ladders, moving objects that are in your path, and other items. In order to combat this growing trend in safety, we will apply the same process of identifying the TBT, the hazards it presents, and how we will protect ourselves from these hazards. First, identify what tasks between the tasks will occur in your job. For example, in this job, we will be climbing a ladder to lock out the lines, walking to the shop and the tool room, and using the freight elevator to transport the pump and the motor. Once you have identified what TBT are involved in your work, you can then look at each TBT and determine what hazards are involved. For example, we identified climbing the ladder as a TBT of this job. Our hazard will be using the ladder and fall hazards. Finally, once the hazards of each TBT has been identified, we can implement precautions or mitigation actions to protect ourselves from these hazards. For example, we listed there are fall hazards with using the ladder. Our precaution will be to use 100% fall protection when we are above 6 foot. At the end of this section, you will be reminded, if additional hazards are introduced, this JSA must be updated or a new JSA created and communicated within the entire work group. Verify with supervisor to determine if changes need to be made to the safe work permit or any other permits that have been issued for this job. The second page of the JSA contains valuable information such as a hazard checklist, a stop work authorization, a sign-off section, a supervisor sign-off section, a job closeout, and an audit section. The final section for completing the JSA before starting work is a guide to help you identify the hazards involved with your work. This simple checklist is useful for reviewing the steps involved in the work that you will be performing and checking any hazards that may exist in each step. This tool is useful because it asks you yes or no to help come up with the hazards rather than coming up with the hazards off the top of your head. However, be cautioned. Not every hazard that you will face in your work will be listed on this checklist. If a hazard is not listed on this checklist, the hazard must be written on the front page of your JSA. A critical principle to remember is your stop work authority. Applying this principle throughout your work at Alston will not only help you to stay safe, but also keep your fellow employee owners safe. Stop work authority is simply stopping and refusing to perform unsafe work. Any employee owner has the right to respectfully refuse to perform any work that you feel violates the federal law, which is OSHA, Alston safety policies, customer safety policies, or anything that you feel represents a threat to the health of yourself or those around you. You have the right to refuse this work without any fear of disciplinary action, so long as you've acted in sincerity. Before returning to work, all problems will be addressed and resolved. Stop work cards will be issued to each employee owner. This stop work card gives the employee owner the responsibility to stop the work when an unsafe act is taking place. Stop is simply about people caring for people. It is your responsibility to look out for your fellow employee owner's safety, knowing that they are doing the same thing for you. When you see someone performing work unsafely, you have the responsibility to stop them and respectfully refuse and explain to them why their actions are unsafe or at risk. If the unsafe act or at-risk behavior is beyond your control, you have the responsibility to inform your supervisor. Remember, when you turn a blind eye to a fellow employee owner that is performing work unsafely, you are basically telling that person that it is okay to work unsafe. And asking me to overlook a simple safety violation would be asking me to compromise my entire value towards safety and your personal well-being. This section of the JSA is to acknowledge that you have reviewed the JSA and understand the task, the hazards, and what steps will be taken to protect yourself from these hazards. You have two columns. The left is to print your name and the right is to sign your name. Next up in the JSA process is your opportunity to finalize or close out the job. This section begins with a reminder that all accidents and near misses must be reported before leaving. That said, it is a requirement that all accidents and near miss events are reported immediately or as soon as possible. Do not wait until it's time to go home before you report incidents. It then asks you some questions. First, was there any incident, injury, and/or near miss? Second, was this incident reported to your safety department or highest level of supervision at the job site? And third, did you clean your work area before leaving? Is all trash and debris cleaned up? Finally, there is a comment section to write anything safety related to the job. You can go into more detail about incidents that happened, stop work actions that took place, and any safety concerns that delayed the work. There is an opportunity for auditing of JSAs that is required at many job sites. This section allows for auditors to verify that they have reviewed your JSA. The JSA is designed to be written as a group with input from the whole crew. We all bring experiences, knowledge, and skills to the group. The JSA is a chance for us to bring those out on a job plan. The more input, the better. The JSA is not designed to have a person sit at a table, write it, and then the crew just signs their name and goes to work. This is counterproductive. Think about it. The whole crew is involved in the JSA process. You are reviewing the JSA as you develop it. When possible, write the JSA at your work area so that you can put eyes on what you're doing. Doing this helps you visualize what you will be doing and makes it easier to write the JSA. It's all about detail, drilling down to find the hazards. The more you dig, the more you uncover hazards, which will lead to more safety countermeasures, which equals safer work. The JSA is a process. The process isn't over until the job is complete. This means you are always on the lookout for additional steps, hazards, and precautions. Always stop when you encounter a problem. The answer is not to apply more force to overcome the problem. The answer is to stop. Identify the issue, figure out a safe way to overcome the problem, and then address it on the JSA before resuming work every time. In addition to the JSA process, there are numerous other tools that we can use to identify hazards before we start work. Safety should be integrated into the initial planning and scheduling of the work request. This is the opportunity for management, supervision, and safety to identify key elements to perform the work safely. Standard safe operating procedures. This could be for cleaning or clearing of plant processes, equipment, or machinery, using machinery or equipment and other things. Having an established safe operating process or SOP can be very helpful in identifying hazards in routine work. Standard safe operating procedures for the startup or shutdown of plant process equipment and machinery. Shutting down and starting up machinery and equipment is critical and is very important to have established guidelines to do this safely. The locking out and tagging out and verifying isolation of potentially hazardous energy is one of Austin's life-critical safety rules. Performing this correctly without fail is critical to ensuring that all employee owners go home safely at the end of the day. Field verification of these procedures is checking to see if the plan has been implemented properly and that all requirements are being followed. Initializing and following all safe work permits for the jobs that we are carrying out. Safe work permits can include hot work, line break, confined spaces, and excavations. A permit is a way to ensure that we have performed all safety requirements before performing these critical jobs. A JSA supports these permits, it does not replace them. Performing a JSA for every job and task that we perform. Remember, no task is so minor that it does not need safe planning. Identifying hazardous chemicals that we work with and consulting the Safety Data Sheet or SDS to understand the hazards and precautions for using the chemicals. Performing pre-job checklists to identify hazards. This includes equipment inspections, and other forms that we use to make sure that everything is operating safely before we start work. The second step in hazard recognition is analyzing the work that is taking place. This step is important because it gives us the opportunity to assess the work that is taking place and ensure that we have identified all hazards involved and taken the appropriate measures to control the hazards. We have numerous tools to ensure that we are identifying hazards and controlling them while the work is taking place. First, supervisors and craft level personnel will perform walkthrough inspections and audits. Supervisors are expected to have craft personnel accompany them along audits because this gives supervision the opportunity to coach them in recognizing the hazards that they see. This helps develop the hazard recognition at the craft level. Supervisors should get with management if they need help in figuring out how to do this. Members of management are expected to conduct audits on jobs that they visit and to take members of supervision along with them as well. Performing equipment inspections to ensure that they are in safe operating condition. Much of the equipment that we operate has the potential to be very dangerous if it is not operating properly. Documented inspections each shift and visual walk around each use will help eliminate the dangers of improperly operating machinery. Management systems are the programs, policies, procedures, and standards that we have established within the company and at the job site. Performing management system audits ensures that the programs, policies, procedures, and standards that we have in place are current and adequate to protect our employee owners. Performing simple observations of your workplace while you are working and taking a 30-second safety pause are effective hazard recognition while the work is taking place. Performing industrial hygiene surveys to ensure that environmental hazards cannot affect our employee owners. Some of the key industrial hygiene monitoring that we do is around hearing conservation and chemicals, stainless steel welding, noise exposure, and certain chemical exposure may require industrial hygiene monitoring. So if you have these on your job site, get with your manager to make sure that we have performed the testing and have adequate protection. We all know that good housekeeping leads to good workplace safety. Performing housekeeping audits can help identify unsafe areas that need attention. Many plants use housekeeping systems such as 5S to get your manager if you think a housekeeping system may work for your job site. Before starting any new task, regularly throughout your task, or when you encounter a problem, the 30-second safety pause is an opportunity for you to stop and ask yourself some of the following questions. Do I know exactly what I am doing? Is there any potential that I could hurt myself? Are there any questions that I should be asking fellow employees? Should I talk to my supervisor? Should the health and safety team be consulted? Do I fully understand the procedures relating to this job? Am I using the proper tools? Should I be using additional or other types of PPE? Will I be working as safely as I know how? Do I see anything that just doesn't look quite right? Am I in a hurry? Would it be safer if I slowed down? Each of these questions should be answered to your full satisfaction before you proceed with the work. Remember, no job is so important or so urgent that you cannot take the time to do it safely the first time. Another take on this is the 20-20-20 rule, which means every 20 minutes, pause for 20 seconds and look 20 feet in every direction to see if everything looks safe and in place. Another thing that is very important to practice is stopping when you encounter a problem with your work. Sometimes you just can't get that bolt to loosen. You can't get the load over the floor, or you can't get the cylinder lifted out of the chamber. All too often, we think the answer is just get a bigger hammer, and usually this leads to accidents. What we should do in these situations is stop. Identify the problem, identify a safe solution, and proceed with carrying the work out safely. Most of the time, just stopping when we encounter a problem is all it takes to realize what we are doing is unsafe. The final stage of hazard recognition is identifying the hazard that caused an accident, analyzing the hazard, and taking steps to control the hazard and prevent it from occurring again. There are several tools that assist us in analyzing the hazard after it has occurred. First, performing a root cause analysis to identify exactly what caused an accident. Communication is key. Once you have completed an investigation on your job site, or you have received a safety flash email, it is critical that you review this information with all of your crew members on the site. Communicating these incidents and their learnings are important in preventing similar incidents from occurring. Second, we can perform action critiques to determine if our preparedness for emergency response or new process startup was adequate. Third, auditing our documentation to ensure that we have trained and planned the job properly. And finally, auditing our safety policies to ensure that they are adequate.